Okay, pre-calculus. So the next set of videos that we're going to be looking at are going to focus on the next unit, which is conic sections. Conic sections are shapes that we know and recognize that can be created by taking a cone, a three-dimensional figure, and then slicing it in some fashion. So imagine taking a cone and just slicing horizontally through the cone, and if you look at what you'd be seeing, you'd see a circle. And so that's what conic sections are all about. We're going to look at 4 different conic sections. You've heard of at least 3 of these for sure, if not the 4th one, but we're going to go through all of them and look at equations and things like that. So the first conic section we're going to look at is a circle. And so we need to define what a circle is. So let's get the definition of a circle up there. And poof, like magic. A circle is a set of all points in a plane that are equidistant from a fixed point. And we know what a circle is, but coming up with a definition that could be tricky. But if we think about what a circle is, the center of the circle would be that fixed point that it mentions there. And all the points that are in a plane, we got to say in a plane on a flat surface because we're not thinking 3 dimensions. So all the points that are the same distance away from the center would be a circle. The equation for a circle is this. And again, like magic, the standard form equation of a circle, because we could write circles in any kind of way, but this is the standard form. X minus h quantity squared plus y minus k quantity squared equals r squared. X and y are going to stay x and y. Think of like y equals mx plus b. You always have a y and an x in there. But the other letters stand for things. So first that h and that k. The h and the k represent the center of the circle on the coordinate plane. So the center is located at hk. Notice it says x minus h and y minus k. So what that means is whatever number is in the parentheses, you're going to use the opposite value of that number for the center. And then the radius is r. Notice that the equation, it equals r squared. And so we have to be very, very careful about not taking the number that's right here in that r squared. Whoop, don't want to switch to the other slide. That number that's in that r squared position, we don't want to accidentally use that number. We're going to have to take the square root of that number in equations that we're going to be using. And we'll see that as we go through some examples. So there's the equation. We definitely want to make sure we have that equation memorized. It's just like y equals mx plus b or anything like that. And so let's take a look at an example that's going to use that equation. And poof, example. Full of magic on these videos. Write the equation of the circle whose center is at -2, -3 and passes through 1, 4. So first we know the center. -2, -3. That's going to be extremely helpful in writing the equation, because as we can see on the equation that we have over here, x minus h squared plus y minus k squared, and h and k are the center. So if I know the center, I've got the entire left side of the equation. So since my center is at -2, -3, I know the equation of my circle is going to be x minus -2, we'll change that in a minute, squared, plus y minus -3, we'll change that in a second, squared as well. That's going to equal r squared. Unfortunately, at this time, I don't know the radius of the circle. However, I do have some information that I haven't used yet. I know the fact that it passes through, the circle actually passes through the coordinate 1, 4. So I can find the center if I can figure out how far the coordinate 1, 4 is from the center, -2, -3. How can we figure out how far apart they are? We can utilize our integrated 2 or integrated 1 skills, and we can use the distance formula. Remember the distance formula? The distance between 2 coordinates is equal to the square root of the difference of the x's squared plus the difference of the y's squared. Remember, this just comes from the Pythagorean theorem. If we were to plot these 2 points, we could draw a right triangle, and the sides of that right triangle would be x2 minus x1 and y2 minus y1, and we'd be looking for the hypotenuse, which would be the distance. So, based on the numbers that we have, we can figure out our distance, but instead of calling it d, let's call it r, because we know that's going to be the radius, right? And so our radius is going to be the square root of the difference of our x's. It doesn't matter which one is x2 and x1, as long as you subtract them. It makes no difference which direction you go. So I'm going to take 1 minus -2 squared, plus, for the other one, 4 minus -3 squared. And so then I just have to work that through. That's not that big of a deal. 1 minus negative 2. All right, that's going to change to plus. Same thing here. That'll change to plus. And so we get 1 plus 2, which is 3. And so 3 squared is going to give us a 9. Plus 4 plus 3 is 7. And 7 squared is going to give us 49. And so we end up with the square root of 58. Notice I kept the square root there. What I often see students do is leave the square root off because they go, oh, I totally remember that it's a square root. I'm not going to bother writing it there. And then they forget. So don't forget that the square root needs to be there. So our radius is a square root of 58. We're not going to change that to a decimal. We're going to leave it just like that. So I can take that square root of 58 that we just found, and I can plug that in for my radius up here. And so my final answer, my equation, I'm going to go ahead and change that x minus negative 2. I'm going to turn that into x plus 2 because we want to make sure we put on the big boy, big girl pants and write things appropriately. Plus, same thing with the y. I'll make that y plus 3 quantity squared. And that's going to equal the square root of 58. Can squeeze it in there. Squared. Don't leave it like that. We know how to square a square root, so our final answer, we should go ahead and square that, and that's going to leave us with x plus 2 quantity squared plus y plus 3 quantity squared equals 58. If we started with this equation, we could see that h and k are there and there, but remember the equation is x minus h, and so really that should be x minus a negative 2, which tells us that h is negative 2. So essentially what you need to remember to do is when you're given an equation to start with, if we're looking for the center, we're always going to go the opposite of the signs in the parentheses to get our actual center. And then we want to make sure that we take the square root of our equals number equals 58, so the square root of that gives us our radius. And so there's our first example of a circle and putting it into standard form. We're going to take a look at one more example on the next slide. All right, so welcome to the next slide. Find the center and radius of the circle. Given this equation, x squared minus 6x plus y squared plus 2y plus 6. Now, in a future video, after we go through all of the conic sections, you'll see how we can tell for sure that this is indeed a circle. But just trust me that it is a circle. Right now, I can't find the center and I can't find the radius because it's not set up in that standard form. So we have to put it into standard form. There are different ways that you can do this. I'm going to go through the most common way. And so if you can find a better way, go for it. But this way is pretty standard and pretty quick. First, I know that I just want a quantity of x squared and a quantity of y squared on one side, and then on the other side I want numbers. So the first thing I'm going to do is I'm just going to subtract that 6. Now when I rewrite the problem, I'm going to leave some space as well. So I'm subtracting the 6 from both sides, and so that's going to leave me with x squared minus 6x, and I'm going to go ahead and leave a little space. There's a reason why. Plus y squared plus 2y, and I'm going to go ahead and leave a little space as well. And because I'm subtracting 6 from both sides, that's going to equal negative 6. Now, why would I leave that space? Well, we need to have x plus or minus something squared. And right now, I don't have that. I just have x squared minus 6x. So we have to do something that you learned back in Integrated Math 2. It may have been a while. It's called completing the square. So just to refresh how to complete the square, or the idea behind it, my goal is to turn x squared minus 6x into x plus or minus something squared. I know that when I square that out, when I do x, whatever that number is, when I write it twice and multiply it all out, I know the middle term's got to be minus 6x. But if I were to get that in there and make that happen, it's also going to give me an extra number on the end. I don't have that extra number on the end, so we're going to force that issue. So let me get rid of all that. So how are we going to force that issue? Here's the process, if you recall. I'll flip it in a different color just so we have that. We're going to take the we call the b value, the number in front of just x, not x squared, the negative 6. We're going to take that negative 6 and we're going to divide it by 2. We always divide it by 2. And negative 6 divided by 2 is negative 3. And then we're going to take that negative 3 and we're going to square it, hence completing the square. Negative 3 squared is positive 9. That should always come out to be a positive value because the process in completing the square is dividing by 2 and squaring it. When you square something, it's always positive. And so I'm going to go ahead and add 9 here because I know if I have a 9 there, then these three terms will make a perfect square, and I'll be able to factor them. That's why we add the 9. Now, I'm not allowed to add a 9 to an equation like this unless I add it to the other side. And so we got to make sure and put a plus 9 over there as well. We're going to do the exact same process for the y's. The number in front of y is 2, so we're going to take that 2 and divide it by 2. 2 divided by 2 is 1, and then we'll square that. 1 squared is 1, positive 1. So I'm going to go ahead and add 1 here, which means I need to add 1 here. By doing all that work in the blue, I haven't changed anything. I added essentially 10 to one side, and I added 10 to the other side, so everything's cool. Why would I do that? Again, it allows me to factor. I can factor x squared minus 6x plus 9. That is factorable, and it's a fast factor. I don't need to think about how that factors. You can go through your process of factoring, but if you know how squares work, that simply factors into x minus 3 squared. That minus 3 is always going to match this number right here, that minus 3, and so that makes it really, really easy. If you were to do x minus 3 times x minus 3 and write it all out and distribute, you would get x squared minus 6x plus 9. So I haven't changed anything, I just factored. I'm going to do the same thing for the y squared plus 2y plus 1. I'm going to go ahead and factor that, and if you are decent at factoring, if you're catching on, that's just going to be y plus 1 squared. Not too bad at all. On the other side, I'm just going to add all of that up. Negative 6 plus 9 plus 1 is 4. This equation is exactly the same as this equation. They don't look the same, but they are the same. Exactly. No changes at all, just simply how they look. And since they're the same, I can utilize this new equation to find my center and my radius. I utilize the numbers in the parentheses to get my center. Remember, the equation is x minus h squared, and so we're just going to do the opposite. If you do the opposite of those values, you're going to be fine. So inside the x parentheses, we have a minus 3, and so my center x value is going to be a positive 3. Inside the parentheses for my y value, I have a plus 1, and so my center, it's going to be a negative 1 for the y value. So the center of this circle is at 3, negative 1, and our radius, we're going to utilize this 4, but remember the radius isn't 4, that's r squared, so if r squared is 4, then the radius must be 2. Completing the square is not a long, difficult process, but it's something it's been a while since you've seen. We're going to complete the square a lot in the next handful of videos, so you're going to get used to it as long as you practice that. The second half of this unit has, or not this unit, but this lesson has parabolas, and we're going to deal with that in the next video. After that video, we'll have some practice problems for you to work on dealing with both circles and parabolas. So until next time, stay safe, and I will see you soon.